Hi guys, I'm gonna try to make this as interactive as possible. I realize it's already the end of the day. I realize this is the last session. It's also scheduled for 40 minutes, but I'm gonna try to keep it a bit shorter because I'm pretty sure no one wants to stay here for 40 minutes. There we go. I can tell you a lot about Eliatra, but considering that we pretty much hijacked the second day of conference, you should pretty much know who they are at this point. I will add, however, that we deal with a lot of queries from customers, and in recent weeks and months, there has been a lot on Kubernetes and operators, so we decided to do a quick talk. There is going to be quite a lot on certificates. I know it's not a sexy topic, and people genuinely don't like dealing with them, but I think we need to cover them, especially the very basics, because we will be using them in operator and the Helm deployments. I will try to keep it as high level as possible, again, in the interest of not putting anybody to sleep. So, about myself, Anton Rubin, technical support at Eliatra. Again, you know about the company now very well, so I'm going to go right past that. What we will be covering today. So, creating the self-signed certificates using CAs and cert-manager, creating production-ready certificates using Let's Encrypt. I'm pretty sure we're all familiar with Let's Encrypt. If not, I will say a few words about it, but I think it's amazing technology. And we're going to configure the OpenSearch cluster using Helm Charts and Operator and run it in EKS. We're going to go over some caveats and some data operations like rolling updates. There's quite a bit of a difference between the two, and some are rather important. So, before we begin, if anybody wants to follow along, watching the recording later on, we will be using EKS, and therefore the first thing we need to do is set up the cluster. The commands on the right-hand side are pretty straightforward. Anybody that's ever done one knows all about it. We'll be running a 5-node cluster, specify the name, and so on. That's pretty easy to understand. Now, the little caveat there, which might catch you out if you're first starting off, if you try to deploy a cluster using Helm, you will not be able to. And it might take a little time to figure out why, and that's because you don't have the permissions and you don't have the driver for the EBS volumes. They don't come out of the box. So we're going to quickly fix that so we can continue with our presentation. So very simply, we get the role earn, we create the policy, we attach the policy, and we install the driver. Again, I'm not going to go through these actual commands. It's just if anybody's watching this and they want to get it running locally, this is the best approach, and it will get you up and running in no time whatsoever. We need to install the cert-manager for a number of reasons. So we'll be creating certificates, and the easiest way that I find is the cert-manager. Once you run those commands using the Helm, again, if anybody's not familiar with Helm, I'll be very surprised, but basically, so that you don't have to worry about all the files individually, you have one values file, which you configure to do all the bits and bobs. And in this case, we install cert-manager, and probably the most important part is the install CRDs equals true at the very end. So the CRDs are the custom resource definitions, which will be used by Kubernetes going forward. Once you run those 4 commands at the top, you will see 3 pods running. The one that you're interested in the most is the very first one. That's the cert-manager controller. The other 2 are more of a helper pods. One is a CA injector and one's a webhook. The controller uses those 2 to fulfill the requests that you send to cert-manager. I'm going over this pretty quickly because this is all basic, and again, don't want to bore people with the obvious. So, to create certificates, there's always a 2-step process, and we'll be doing this again and again and again. So once you wrap your head around this, the rest is pretty simple. The cluster issue is the first step. I try to highlight, I hope it's visible, I try to highlight the parts that are quite important. The first thing is the cluster issue in this case is self-signed. So we're going to create a master certificate that will then be used to sign the rest of the certificate. What that means is you have your own CA, it's private, only you know it, and you sign the rest of the certificates. The problem with that is if you try to use them in things like a browser, it will yell at you and say, I don't want to, I don't trust it. The second part is to create the actual certificate. Notice the CRDs that I mentioned, that's the kind. So in the first one, the CRD is the cluster issue. The second one is certificate. Now we can use them. We create the CA for 5 years. We name the secret where we want to store it. And at the very bottom, we specify that we want to use the issue reference of self-signed. Once you do all that, you can have a look at the secret that you created. We call it CA key pair. And the CA CRT and the TLS.crt are the same size. There's a very good reason for that. It's because it's the same file, which is where we get self-signed. It's important for the future, but for now, just to be aware of it. Now that we have the master certificate, we're going to create all the baby certificates, right? So we're going to reuse the same certificate for transport and HTTP layer on OpenSearch, just in the interest of keeping things simple. We're going to use a separate certificate for dashboards to create the HTTPS, and a third one for admin certificate for using the security admin and special APIs. To do that, again, like I said, two-step process every time. We have the cluster issuer. The only difference this time is we specify the CA that we have already created, and that's the secret called CA key pair. Of course, the second step then is to create the individual certificates. We're going to have the transport and HTTP. We're going to have dashboards and admin. I highlighted the important parts. They're all pretty straightforward. So we have the dates, when we want to have them renewed. The most important part, again, is the issue reference, which is the cluster issue from CA, which is the cluster issue that we created over here. So once you have all these three, and you apply them using kube control, apply -F, you will have three services, three secrets. The names that we provided, and if you have a look at them, you will see that the CA that comes with them is actually the CA that we created at the very first step. I mean, obviously by the size, but you can go in and actually double check it yourself. So that's self-signed CAs. I know I flew through it. It's not the most exciting stuff, but in this case, it's the certificates that we can use ourselves, and they're production ready. It's not like a demo certificate that everybody else has access to. They're production ready. It's just if we try to use them out in a while, nobody tries them, and that makes sense. So let's encrypt. First of all, what's Let's Encrypt? Pretty straightforward. It's, well, years and years ago when I thought that to have a certificate, you have to fill out the paperwork, you have to send it in, you have to pay the money, you have to wait. It was pretty cool to come across technology like Let's Encrypt, and suddenly you get all that for free in seconds. It was hard to believe that that actually exists, but it does. So you get production-ready certificates that are trusted by the browser. And to obtain them, it's actually a very straightforward process. I mean, there are two ways to do it. One is super easy, but there is a caveat. The other one is the DNS challenge. And it's a little bit more complex, but very, very simple nonetheless. So HTTP L1 challenge, it uses the port 80. So if you have port 80 blocked off, you won't be able to use it. If you don't have it blocked off, it's super easy, and you'll get it done in seconds. And then we have the DNS challenge. We'll cover this both very quickly again. There is not much to it. But before we do that, Let's Encrypt will, when you try to obtain those certificates, obviously, to solve the challenges, you need an ingress resource. To be able to have an ingress resource, you need to have ingress controller. So before we do that, we're going to quickly install ingress controller, everything out of the box, no custom configuration. You can configure it any way you want. There is a million and one ways to do it, but obviously for the sake of this presentation, we're going to use all the very basics. And you can see the pods running, and there's only one pod, and that's all you really care about. Then we move on to the HTTP challenge. So again, two-step process every time. Cluster issuer, then the certificate. In this case, the cluster issuer, we will name it Let's Encrypt prod. Great. Then we have the prod and the stage Acme servers. So what is the difference? The prod is obviously production ready. That's what you want. What's the caveat? There is a quota. There is a limit as to how much you can request. So be careful playing with these in staging, because you will run out pretty quick. The limit is actually very, very small. So staging works every time, no limit within reason, but is similar to the self-signed certificates. They're just not trusted by anything else. DNS challenge. So this is the other one. So a little bit more configuration, mainly because you need to save the AWS token as secret, And then you use that in your DNS challenge under the solvers. In my case, we have Eliatra support.co.uk, DNS, Route 53, so on and so forth, and that's where your secret goes. So it's a little bit more, but again, nothing crazy about this, I think. And in both cases, we create a secret, and we name the secret whatever we want. In our case, let's encrypt prod. I'm sure you can see what I'm talking about, but I'm not going to start messing with the laser. Never fun. Certificates. So we did the first step. We have the cluster issuer. The second step, of course, is the actual certificates. And in our case, we simply pointed to the cluster issuer that we have created. I can go through the details, but I don't think it's important. It's exactly the same thing as we did before, except now we're pointing to the new issue reference of the cluster. So that will create our certificates. I do want to jump in the demo at one stage, but I'll wait for the right time. It's not exciting to look at terminals, and to kind of show this, you have to look at terminals. So it's not super exciting. Now, this is an interesting one, actually, and I'll bring your attention to this for a reason. I will ask you a question about this later. But for the dashboards, obviously, we don't want to store sensitive information in a YAML file. So one of the best ways to do it is to create a secrets file. But in this case, notice the username and the password is highlighted in bold. That's for a reason. I'll come back to that. Dun, dun, dun. Helm. We already heard about Helm. I know it's not pretty to look at screenshots, and I can go and show the actual repo, but Helm lives in that URL, in that Git repo. And when you open it, the very first screenshot, you will see it has a bunch of files. The one you're interested in is charts. And in charts, you have two folders, which is OpenSearch and OpenSearch dashboards. They both have the same structure, and you will get familiar with them if you're working with Helm. If you're already working with Helm, you're already familiar with them. The file that you will be working with 99% of the time is values.yaml. So you have one YAML file that you're going to configure all of your containers, all of your configuration. And the same for dashboards. I was going to go and show this, but I don't think there's a point. So Helm files. We're configuring one YAML file for OpenSearch, and all of our configuration goes into this file. We have the security configuration, which if you went to the talk from Niels today at 1 o'clock, you would have heard all about the configs and users and roles and mappings. So all of this goes into the data section of the security config. It is my favorite way of doing it. There's other ways with secrets and stuff, but this is very straightforward, and for demo purposes, definitely the way to go. The certificates that we created. So we created the self-signed, and we created the Let's Encrypt. Whichever way you've done it, you can map them using the secret mounts. You specify the secret and where you want to store them. In this case, we're simply mounting the OpenSearch certs and the admin for running various APIs. One important extra environment is the disable install demo. Otherwise, all we did was for nothing, and that would be a shame. So yeah, add that in so that it doesn't overwrite your configuration. And then last but not least, of course, is the OpenSearch.yaml file. This is the usual configuration that I'm sure you're familiar with. You add everything that you want, all the DNs, all the security plugin, everything that goes into the OpenSearch.yaml file. So one file to rule them all. Pretty handy. If you didn't have Helm, you would have to configure secrets, you would have to configure stateful sets, services, link them together. It's a bit of a nightmare to try and work with it. So Helm solves that problem. We configured OpenSearch, but now we need to configure the OpenSearch dashboards. Surprisingly, it's not much different. You have your configuration, the usual OpenSearch dashboard configuration. Now, you see the highlighted part in bold? OpenSearch.username. Does anybody remember what was the key that we used for this secret for OpenSearch account? It was starting with A, right? Good try. It was username and password. It wasn't OpenSearch underscore username. It wasn't OpenSearch underscore password. This creates confusion at times. The reason for that is because the secret that we created called OpenSearch dashboards account, when we add it into OpenSearch account field in the values file, it looks for those keys, password and username, but then it maps them to environment variable called OpenSearch.username. So if you go into the container and look at the environment variables, you will see that that environment variable is actually the secret that you created. And of course, last but not least, we do the certificates as we did before. So nothing super advanced here. Deploying is, as you would imagine, you cd into the OpenSearch, you cd into OpenSearch dashboards, you do Helm install, and if you look at your pods, you have 4 pods running because we configured 3 of master and 1 of dashboards. Now, anybody who's worked with Helm will know this, so if you know the answer, maybe don't shout out, but somebody who's not familiar with Helm too much, what is the problem with this approach? What is the limitation that you see, the kind of the, I don't want to say the obvious one, because that's just not. Any takers? So what happens if you want to run 1 master, 1 data, 1 ingest? Anybody else?
Step on each other.
They step on each other. They don't really step on each other. Well, depends. No, it's not that so much. It's, you will have to go in and create 3 values files, 3 deployments, 3 of everything, which is a pain. So if you're doing upgrades, now you're upgrading one by one. So anybody who's familiar with Helm, they usually end up building a layer on top of Helm that does that for them. There's a lot more configuration involved. There's dev work. It's not the prettiest. But in my opinion, at least, this is the biggest shortfall of Helm, because nobody wants to do that, and usually you wouldn't run a cluster with just all master nodes and all data nodes. It doesn't happen in the wild. Basically, summarizing what I just said. Summarize. So separate values file, 3 separate deployments. Assuming you want to run 1 master, 1 data. If there's more, then it's more deployments, more for you to manage. So yeah, Helm has this problem, and you need to be aware of it. This is the other one, and this is one that people get caught up quite a bit on because it looks like it does what it's supposed to do, but it doesn't really. So when you're doing updates, the role in updates, from a perspective of pods, it does go after 1 pod at a time, waits for it to restart. When it's up, it moves on to the next pod. So it looks good. But under the hood, what's supposed to happen doesn't happen in terms of OpenSearch. When you take down a node in OpenSearch, first you need to disable shard allocation, because what happens is the shards will go, oh, geez, I lost a node, I need to move. So if you have a lot of shards, a lot of data, it's very expensive to do that. Helm doesn't do that out of the box. It doesn't do that. But it looks like it does, because your cluster does recover and everything looks fine if you run in test mode. Now, the problem is, it's not really the problem, but maybe the lucky part is that the default timeout is 1 minute before the shards start moving around after they lose their owner. So usually, when you especially run it locally, your container goes up and down, recovers, everything works fine, and it moves on. The problem is if it takes longer or there's a problem along the way, it never checks whether the cluster actually recovered, if the state is actually green. So if any of the shards are still unallocated, the state will be yellow, but it will keep going. And obviously, the consequences can be dire. That's the other caveat. The possible workarounds are pre and post hooks. There is various options to work around it, but you can basically configure to say, before you do something, check this. After you do something else. That's the caveats. So that kind of brings you to the operator world. It solves all of these problems. It lives in the GitHub repo that you see on the screen. Again, I'm not going to go into it and show. I don't think it's that exciting to look at that. You install it using the Helm repo add, Helm install, the usual as we did before. You can configure it using the values file when you install the operator. For the sake of the demonstration or for the sake of the talk, we'll just use all the usual defaults. And you should have 2 pods running. Once it's up, and it takes maybe, there you go, 52 seconds. So you should have 2 pods running. The second one is the one that you're interested in. If something's not working, that's the one you want to get the logs from. The kube RBAC is not going to give you much information. Interesting caveat at the bottom. Can't run a single node cluster at this moment in time. It just doesn't work. You need a 3-master node cluster at least. Configuration. So previously we said that we need different deployments for Helm chart. Now the beauty of this is obviously you don't anymore. So the screenshot is from the Helm GitHub repo, and there is a couple of examples there. The one that you're really interested in is the OpenSearch v2, which is everything for OpenSearch v version 2 and above. And you're looking at one file. There's only one OpenSearch cluster file, which is the new CRD that was provided by the operator. And you add all the configuration in that one file. It is very easy to use. We're going to go through the number of configurations now, but one of the great benefits is the node pools. They create separate stateful sets for each node pool. So now you have your masters running separately. Now you have your data, your ingest. You can configure everything relating to that node pool completely separately, and it'll work. All the replica sets, of course, and so on. So that's one of the major benefits that Operator brings over Helm. Configuring TLS, always the exciting topic. There are 2 ways to do it. 2 ways to do it. You can let Operator manage it, and you can wash your hands. Or you can import your own configuration. Of course, if you import your own, there is quite a bit more that you need to specify, because now it doesn't know anything about the certificates that you're importing. If you let it generate certificates, you just need to specify 2 options. Whether you want to generate it, of course, you say yes, and whether you want it per node. This is on transport level, per node certificates, which means, of course, every node will get its own certificate. If you import your own, yeah, you have to specify the CA secret, the node's DN, because it doesn't know the node's DN, the admin DN, same very concept. And the configuration goes in the security TLS section, very straightforward. Now, I know this is quite maybe a dry slide, but the best part is the rest of the certificates work exactly the same way. So if you manage to survive this one, the rest should be easy. And bottom right is just a little caveat. If you are importing your own, make sure the host.key and hostname.crt is important so that it knows which certificate goes to which node. Catches people out as well. On the HTTP level, like I said, it's exactly the same as the transport. The only difference is there is no per node configuration. And if you're importing your own, make sure you add those names, tags, to a subject alternative name so that it functions as expected. Again, the actual configuration is on the right-hand side. You can see it's almost identical to previous. Additional configuration. Now, this is a good one, and I do want to demo it because it's a bit tricky. So, yeah, no, this is a spoiler alert. Wait. I hope I'll be able to go back to this after. Okay. This is the file that, yes, you can see it, I hope. Is it too small, guys? Works okay? Right. This is the file that we use to deploy OpenSearch cluster. Notice the additional configuration that I just kind of hinted at. Under the node pools, you can specify a configuration, and under general, you can specify configuration. Obviously, the general part will apply to all of them. Under the node pools, it will apply to a specific one. In this case, I overwrote the same one. mainly to test which one is going to take. Of course, as we expect, when you specify the node pools, that's the one that will take precedence. But there is something more interesting here. To reload certificates, I'm not sure if anybody ever done that, but to reload certificates, you need to pass in plugin security SSL cert reload enable true. So we added this under additional configuration. Now, this is the part where we have to look at terminal, which is not great. This is the OpenSearch.yaml file inside the container. If you notice, it's not there. At least I hope. Otherwise, I just shot myself in the foot. But it's not there. But if I go and I try to reload a certificate, it worked. So something doesn't make sense. Any guesses how that's possible? Any at all? There's no stupid guesses. Okay. The caveat to all this is environment variables. So the configuration that we passed, it doesn't update the OpenSearch.yaml file. This catches out a lot of people. It might seem simple enough, but when you're looking at this every day and you're used to working with OpenSearch.yaml files, and if it's not there, you know that it's not going to work, then all of a sudden this comes along and it works, but you have no idea why. Environment variables. And you will see that actually it uses environment variables extensively for a lot of your configuration. That is not the case with dashboards. So dashboards file will actually, OpenSearch dashboards.yaml file will actually contain all of the configuration that you mentioned under the additional config section. So I just thought I added a little additional super header there called Anton header. And yeah, just to make sure that it doesn't appear separately as environment variable, it just everything gets added to the OpenSearch dashboards.yaml file. So I just wanted to show you this in case you come across it and you will remember this talk and you say, oh yeah, I know exactly where it is. So yeah, this is why I wanted to hide the bottom part as an environment variable. So we have the additional configuration per node, per node pool generally, and then the very same for OpenSearch dashboards file, which is on the next slide, I believe. Okay. Security configuration. So 2 ways to do it. Operator brings you an additional way to do it, which perhaps surpasses my favorite way. But you can either create and mount a secret with all the security configuration. Very useful way to do it. Again, my favorite way to do it. But the new way is you can use the operator resources. And it's part of the new CRDs that were added as operator. And we will look at them now. Now, just don't use both at the same time. Not a good idea. They override each other, and they clash, and they cause problems. So choose one and go with it. In the future, there's hope that they will be combined, but at this moment in time, that's not happening. So the configuration using the secret is straightforward, which is, again, why it's my favorite. You add all your files with all the data, all the internal users, the roles, tenants, so on and so forth. And you add them under security config secret. It's that simple. It's, I like it. Yeah. The second way is a bit more complex, I think. So there's the CRDs, OpenSearch user, OpenSearch role, OpenSearch user bindings, OpenSearch tenant, and so on, and you configure them separately. So in this case, we are creating a sample user with a password, backend role, which is map, and so on. So you can use these resources. It's the new option. Just a little caveat at the bottom there. If you're using this method, the secret, needs to exist in a default namespace with base64 encoded password and password key. There is quite few issues around that, but once you know that, you should be good to go. Max map count. I think anybody who's ever worked with OpenSearch has come across this error at least at one point in their life. So OpenSearch needs the max map count to be at least 262,000. Of course, you can manually go into each node and run the syscontrol command, but you can save yourself the trouble and set the VM max map count to true. Now, that's all great, but all these helper containers, init containers, helper containers, they run as root. So if that is a problem in your environment, you might want to disable them. And that's the parameter at the bottom right. Skip init containers, value true. You can also customize them, so there's a bit more in-depth knowledge needed there. But ultimately, yeah, just to kind of point out that they will run as root, and it might cause issues and might not run for you if that's not allowed. Configuring dashboards, very straightforward. Not much to say about it. Specify the version, the replicas, and enable it to true, and then specify all your configuration under one setting. And the variable substitution comes out of the box, so it's pretty straightforward. It's just an example where you have environment of OpenID client secret, and you specify it in your additional configuration. So the top and bottom, obviously, is additional configuration. It's the same thing, except in the second one, you're just using the secret. I hope that's clear. Dashboards HTTPS, again, very similar to previous HTTP. That's what I said, that if you wrap your head around the very first one, the rest of them kind of fall into the right place. Again, because you are using either self-signed certificates or you're using certificates generated by operator, they will not be trusted by your browser, and it will be shouting at you, and it won't like you. The recommendation, of course, is to use accredited CA, like Let's Encrypt, and now we know how to do it, so happy days. And I'm nearly there, guys. Bear with me. This is all the additional configuration you can, or most of the additional configuration you can configure on operator. I think the only one that I will bring up is the small scaler, which is, again, to switch it on is just set it to true. It's super simple. But the beauty is that if you are downscaling, which is a usually challenging task and risky task, it will drain the node before taking it offline, which is super cool. You won't lose any data. So that's an additional feature that comes with operator, which is very, very useful. And the rest of them, yeah, you can have a look at yourself. It's in the user docs in the same GitHub repo. I'm nearly done. So 2 things with rolling updates. Yes. So we said before that Helm has a problem. That problem is fixed with operator. We have shard allocation is disabled on each node prior to restarting it. After you restart it, it's enabled. The health is checked. Then it moves to the second one. So visually, if you compare the two, it almost looks identical. But under the hood, you get a lot more safety and security with the second option, because it does check your cluster. If something goes wrong, it doesn't do it. Whereas with Helm, it's just like a tank. It just rolls over it. Changing OpenSearch YAML configuration is on an already installed cluster will trigger the roll and restart on all the nodes and apply the new configuration. The same applies to any annotations and resources and labels and so on. A little caveat at the bottom, downgrades that span more than one major version are not supported. It could leave your cluster in a very unhealthy state. Certificate expiration. Now, I know I'm almost out of time, I know, but this slide should be in bright red with alarm bells and everything. It was mentioned already today by the talk that Niels did. I just need to bring more attention to this. If you deploy a cluster today using an operator that creates its own certificates, and you don't have a certificate renewal policy in place, some sort of architecture to renew them, it will die a year from now. It doesn't matter how many times you say this, there's still people who go, so yeah, I love this, I'm going to prod, and then the rest surprises. Now, there is good news. you can reload them like we just did with simply adding that configuration. And if you delete a secret in Kubernetes, it gets regenerated by the operator, by cert-manager, by anything you're using, by Let's Encrypt. It will get recreated with the new date. So it's not much. And even if you don't reload it and you change some configuration in OpenSearch, it will again run run an update every node and restart it and do it safely. And you won't lose any data. So it is a huge caveat, and it needs to be it needs to be made aware of. So I just thought to bring it up again on this. And of course, we created Ingress using the Let's Encrypt certificate, and as a result, we are able to access it using the browser, and the browser is happy enough with the certificate. You can actually, anybody that wants to do it can go to Eliatra support.co.uk, and they will see this running in the cluster at this moment in time. That's what we covered today. So we created and configured EKS cluster. We deployed cert-manager. We created self-signed CAs. We used Let's Encrypt to generate all the CAs. And then we configured OpenSearch using Helm and Operator and had a look at roll and update. And that is me. I actually thought it'd be quicker, but it wasn't.
Thank you. Thank you very much for a great presentation. Now we know how to operate OpenSearch by using Kubernetes. Does somebody has question? You have questions, okay?
Thanks. That was a lot of information in a short period of time, but it's great. So I have a doubt related to the certificates you use. So you were using RSA of 2048 bits. That is the recommendation. So are you testing also to use ECDSA? I guess that the same size is 224 bits. I know it should be faster because you are using less resources, but I didn't have any metric related to that. Did you try ever?
I haven't tried other certificates, no. I focus more that I don't want to put the conversation onto the types of certificates we use, as long as there are some certificates that you know how to work with. So we kind of focus from that point of view. There is a lot to be said from any certificates. So there is so many different configurations that you can apply, and I'm sure you know yourself, that this wouldn't really be the talking point about operator as such. It's more about in general, like of course, the bigger you go, the heavier it is. So there's, so to answer your question, no, I haven't tried different. I just, if it works, I kind of move on and say, okay, you can use whichever source you want to use, as long as the rest of the configuration is working.
Perfect. Thanks.
Yeah.
I have an answer for you. So I did a performance talk, OpenSearch performance talk a year ago. So we tested all different kinds of certificates. So in theory, elliptic curve certificates should be faster. They are not.
Okay.
No difference.
I was just thinking. Thanks.
There we go.
You. Who has the next question? Okay, you.
Two questions, actually. Do you know if the environment variable for the certificate hot reload is available for the Helm chart deployment as well, or is there a specific function of the operator?
Oh, no, that's OpenSearch.
Okay, so we can just set the environment variable and have the...
You can, even if you run it locally, you can do it.
Okay, that's nice.
Absolutely.
And the second question, you mentioned the configuration with the security admin.sh. Would you still recommend that? Because as far as I know, it's marked as deprecated and should be replaced by something in OpenSearch 3 or version 3?
It's still there at the moment.
Yeah, but marked as deprecated, if I'm not wrong.
Don't think so. I mean, you can still use it. Maybe it's deprecated where you shouldn't use it going forward, but no. If you want to initialize your cluster without letting it initialize itself when you start it, you would have to use security admin. So if you say, no, I don't want it to be auto-initialized, I want to do it myself, then you need to use security-admin.sh with the certificates to initialize it.
Okay.
I hope that answers your question.
Yeah,
If it
but I
doesn't-
also need
Now, maybe in the future it's been deprecated.
I thought I already saw that in the OpenSearch logs, but maybe I'm wrong. I need to also check that again.
you could very well be right, yeah. But how else would you initialize it, I wonder? If it's
Right
not
now, we are also
auto-initialized.
doing with security admin,
Okay, right.
but we don't do the configuration of further roles, users, etc., using the security admin. We just initialize the index that is created, and
Right.
then we're using OpenSearch dashboards and therefore the API to add further roles mappings, users, etc. But we don't add them in the security admin in the configurations files.
Yeah, that's a very common way to use it. I mean, it's not great to use the files, even with operator and so on. It's the initial configuration that once it's there, you really wouldn't be changing those files. You'd be using the UI and API. It's so much user-friendly, right? But the initial setup, yeah, if you don't auto-initialize it, which I think might be one of the slides where I set it to false or to true, but the setting is there. But if you set it to false, it needs to be initialized manually. And that's what the security admin is for. And maybe that's going away in the future. Maybe we just auto-initialize in the future. But for the time being, yeah, you still have to use it.
Okay. Yep. Thank you.
Pleasure.